All right, today we're talking about linear transformations. Well, the linear parent function is right here. F of x equals x, right? And f of x is the same as y, so this is y equals x. So a parent function is the most basic form of that type of graph. This is a linear function, right? First four letters in linear are aligned. Every straight line is a linear function. All right, so all of the graphs and equations in that function family are created by transforming the parent function. So every other linear function is born from this f of x equals x, our most basic linear function. All right, because I mean, if f of x, look at this part, x, what's the slope? Well, the slope is 1, right? There's 1x. I go up 1 over 1, up 1 over 1. So my slope is 1. And my y-intercept is 0. Cannot get any more basic than the slope of 1 and a y-intercept is 0. Where our domain, or domain is all my possible x values. Well, this goes forever left and forever right. So our domain is all real numbers, right? Because it goes forever left and it's going forever right. Our range is all our possible y values. So I check top to bottom. Well, it's going forever down and forever up. So our range is also all real numbers. That's our little fancy symbol for all real numbers. So let's see what happens if I take my parent function, f of x equals x, and I make it negative f of x. So I'm going to see if I can flip my screen kind of and share this. Let's see if this works. Hopefully you're seeing my Desmos screen. So I have graphed f of x equals x. So let's see what happens when I graph negative f of x. You notice like, well, it's the same exact line, it's just opposite, right? If it's going down, it's like a slope, the slope is negative. Anytime my slope is negative, I should be going down. So what happens is that in reality, all my points on this line, like where on my original line, where x is -5, and my y was -5. Well, now it's gotten flipped and it's above where, so now -5 is actually +5. So in reality, all that we've done is we've reflected or flipped our line across the x-axis, right? Every point here, now it's the opposite across my x-axis. So we're gonna go back to our notes. All right. So multiplying a function by a negative value makes it reflect or flip across the x-axis. So our negative f of x was the same exact thing. It was just negative, right? I have to put all my dots, so that helps me make as straight as line as possible. So negative f of x is just the same exact line. Just everything is flipped over the x-axis, right? Instead of 4, 4, well, now it's 4, -4. Instead of -5, 5, it's negative, or -5, -5, now it's -5, +5. So everything just got flipped over our x-axis. Well, that makes sense. Like when we have a negative slope, it goes down. All right, makes sense. So now let's see what happens when I multiply a number times f of x. So I'm gonna switch back to look at our Desmos screen. So let's click here. So let's see what happens if I make a greater than 1. You notice as this number increases, our line gets more and more vertical, it gets steeper, right? Because really this a is my new slope. Instead of my slope being 1, well, now my slope is 2. So I go up 2 over 1, up 2 over 1, up 2 over 1. So if I make my number more than 1, it gets more steep. So I'm sure you can predict what happens when I make it less than 1. It gets less steep, it gets flatter. Okay. So multiplying by a number just changes the slope. So back to our notes. Multiplying a function by a value affects the steepness of the graph. If a is greater than 1, the graph will get more steep. If a is between 0 and 1, the graph will get less steep. And I say between 0 and 1 because if it gets negative, well, negative is going to make it flip over the line, right? So again, we're just looking at the value of the number, not is it positive or negative. So if it's negative, I know it's going down, just the value. So if it's less than 1, it's going to be less steep. So this value is the slope of our line. So like 2 f of x is the same exact line, just my slope is now 2. So 2 f of x. It's just our line. I took my line and now I just made it, I used my original line, but now it's just steeper. Okay. And likewise, if I do 1/2 f of x, well, again, 1/2 is my slope. I go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. So 1/2 f of x. Well, so since it was less than 1, our graph, right, instead of being like this, well, it got a little flatter. It got less steep. So in general, the main idea is when I multiply, so multiplying by a value changes the steepness. So multiplying just changes, is it more steep or less steep? In general, that's how we're going to remember it. So let's talk about, let's go to our other options though. What are other things we could do to this line? Well, I can like add or subtract numbers out here on the outside. Let's go back to our Desmos. So see what happens when I add or subtract a number on the outside. So if I add on the outside, ooh, you'll notice if I make this +3, it shifted our whole line up 3 units. Well, yeah, because this looks like the y-intercept out here, right? All of my points, every point on my graph has now been shifted up 3 units. So when I add, it shifts our graph up 3. Let's see what happens when our graph when it's negative. If I subtract the number, it only makes it go down, right? If it's -5, well, that means my line is now shifted 9 spots down. Or 5 spots down, not 9 spots down, 5 spots down. Okay. So back to our notes. When we add something to the end of the function, it shifts it up. Right, like x plus 4 is going to shift our function up 4 spots. All right, this got shifted up 4. Or if I subtract something on the end, well, it's gonna shift it, shifts the graph down. Right, when it was x minus 4, well, all that happened was our graph went down 4. Okay, all right. So again, nothing too crazy. I'm gonna put up here, add, subtract equals the shift. So when we multiply, that affects how steep it is. But if I add or subtract, we're just shifting our graph either up or down when it's on the outside. So far it has been very tricky, but this is where it can get a little confusing. So now we're going to see what happens when I add or subtract on the inside. Well, when I'm adding on the inside, I'm literally adding to my x value. And my x-axis goes left and right. So we're changing our graph. We're going to either move our graph to the left or move our graph to the right. So let's go back and look at this one more time and see what happens. All right, so we're not looking at C anymore. Now we're looking at what happens when I add or subtract on the inside of my line. Oh, sorry, I meant to do this. So if I make it x plus 2, let's see what happens. Oh, well, when I added 2, it actually made my graph go left 2. Like, to me, that seems the opposite, because I know plus 2 is over here on my x-axis. When I added 2, it shifted my graph to the left 2 spots. Let's see what happens when I get a negative 2. When I make a negative 2, it goes to the right 2 spots. So it's always the opposite of what I think it's going to do. All right, when it was minus 2, it actually made it go to the right. So that's where this can get tricky. When we're talking about those C values, it's never what we think is going to happen. It's always the opposite of what we expect. So when I add something inside of the function, shifts the graph, right? In my head, it should go right, but it didn't. It shifted it left. So it now hits my x-axis 3 spots to the left. So it's still our same line, just left 3. And when I subtracted, well, it shifts the graph to the right. Right? In my head, negative 3 is in the left, but I remember everything inside does the opposite. So it's actually making my graph go right 3. So I know that's the part that's confusing to people. They're like, why is adding going left? So let's look at this. Anything happening outside the parentheses affects the graph vertically. And anything happening inside the parentheses affects the graph horizontally. And it does the opposite of what you think it should do, right? When it's x minus, in my head, I go, all right, everything inside's horizontal, but everything inside's the opposite. Minus should go left, but it doesn't. It goes right 3. So I'm going to add something down here. I want you to write this down. All right, I'm going to write down here. Inside equals horizontal equals lie. I'm going to say outside equals vertical equals truth. Right? When it was outside my parenthesis, well, adding made it go up. Well, that makes sense. Subtracting made it go down. That makes sense. So outside was a vertical change, up or down, and they made sense. But when it was inside my parentheses, it was a horizontal change, and it's the opposite of what I expect. Adding made it go left. Subtracting made it go right. And the way I remember it, I want you to, hopefully this will help you. When I am horizontal, means I'm lying down, right? Because horizontal is like this, right? So if this is a person here, they're laying down in bed, they are lying down in bed. So I think, all right, horizontal means I'm a liar. So I'm lying down. Everything inside my parentheses is a horizontal change. When I'm horizontal, I'm lying down. That's how I remember it. Okay. So now let's do some practice. we're going to identify what transformations on the parent function occurred. So if it's negative, well, that just means it reflect across the x-axis, right? So anytime I have a negative, that means it got reflected. So now it's going down. If I multiply by a number more than 1, it's going to get more steep. If I multiply by a number less than 1, it's going to get less steep. No, again, pretty obvious. If I add 6 on the outside, that's a vertical shift up 6. If it's -1, again, outside tells the truth, and outside's a vertical change. So vertical shift down 1. Right? The ones inside the parentheses, I remember like when we did point slope form, remember our number is always the opposite of what it looks like. It's another way I can help remember that. Oh yeah, it's always the opposite. So this is going to be a horizontal shift. Remember, in my head, negatives are to the left. The inside's lying to me. So this is really right 4. This one, horizontal shift +9. Oh, in my head on a number line, +9's to the right. But I know the inside's lying to me. The horizontal, I'm lying down. So this is actually left 9. However, there's not always just one transformation, right? Usually there's more than one. So we're going to write down all the ones that are occurring. So anytime I see negative, man, that reflects across x-axis. That's what the negative tells me. And this +7 tells me it's going to be a vertical shift up. I'm just going to put up 7. So my next one. Let me see. I have that pulled up on my. Let's see if we have flip back to our Desmos. All right. So here's my basic one. F of x equals x. So negative f of x plus 7. The negative means that it's going down. And my line got shifted up 7. So instead of going through my y-axis at 0, it goes through right here at 7. Yeah. And my slope's still -1. But since it's negative, it's going down. And instead of going through the origin, it got shifted up 7. All right, back to our notes. So now multiplying by a factor of 2 makes it more steep. And subtracting 3 on the inside. Inside's horizontal. When I'm horizontal, I'm lying down. So I know -3 looks like it's going left on my number line, but this is really going to make it go right 3. Let's get these other two. Negative means it's going to reflect across the x-axis. So it's going to reflect 5/3 is more than 1. So it's going to get more steep. And this -2 is on the outside. Outside tells the truth. Let's make it go down 2. Last one, so I get this negative. Well, it's going to make it reflect 2/7 is less than 1. So it's going to get less steep. This +5 is on the inside, so it's the opposite. So it's going to go left 5. It's +11's on the outside. It tells the truth. It's going to go up 11. Let's go back and look at our Desmos last time. All right. So 2 f of x minus 3. The 2 makes it more steep. So you'll notice our line is definitely steeper. Our slope is now up 2/1, up 2/1. Since it was -3 on the inside, it made it go to the right 3. So instead of hitting my x-axis at 0, it hits my x-axis at +3. Yeah, it did exactly what we thought it should do. Let's look at our next one. -5/3. So the negative makes it go down. It flips it over the x-axis. My slope is now 5/3. So if I find a corner, I go down 5/3, down 5/3. Yep, that's the right slope. And since it got shifted down 2, so instead of going through my y-axis at 0, it goes to my y-axis at -2. All that was right. This last one was a doozy. All right, so -2/7. It's going down, so that's got the negative part right. My slope is 2/7. If I find a corner, right here, it goes down 2/7, down 2/7. But it got shifted. All right, +5 makes it go left 5, so go over 5. And then +11 makes it go up 11. Oh, right there. Yeah, that's where my line is. It got shifted left 5 and up 11. Okay, so let's get some practice. So I got these problems on the back. All right, so when I see -7, well, that's on the outside, so I know it's a vertical change. And when I'm adding or subtracting, that means we're moving our graph. We're not changing the steepness, right? Steepness is when we multiply. So I know it's not B, and I know it's not D. So outside's vertical, and vertical tells the truth. So -7 should make it go down 7. Number 2, I have x plus 3, but it's inside my parentheses. Inside is horizontal, so it's either got to be left or right. So I know it's not up, and I know it's not down. So in my head, +3 is to the right, but I got to remember, it's the opposite. So it's actually left. Number 3. Let's see what we got. Oh, I got a negative. So the negative means that it's flipped. So I know it's not A, and I know it's not D because they're not flipped. Adding 4 on the outside is a vertical change of +4. So it got shifted up 4. Oh yeah, C got shifted up 4. B got shifted down 4. That's not right. So number 4. All right, well, our lines are both straight through the origin. So they did not get shifted anyway. So this -2 and this -1 are obviously wrong, right? Because subtracting would make it shift. But so our original line is f of x, and our new line's g of x. We got less steep. It gets less steep, needs to be less than 1. All right, last 2. The graph of linear function h is shown in the grid, given f of x equals x and h of x equals a f of x. What is the value of a? So what do we multiply by to get our new function? Remember, f of x is x, so it would just be a slope of 1. So a is the slope of our line. So let's see, how do I get from this point to this point? I go up 2 and over 5. So our slope is 2/5. So that is our a value. What did I multiply to get this one? Well, I took my f of x equals x, and I multiplied it by 2/5. So that made it more flat, less steep. All right, last one. So this plus D is on the outside. So now that means it's a vertical change. So instead of going through the origin, well, it went down, and now it crosses at -6. So my D value is -6. All right, guys, I know this is not an easy concept. I just got to remember, everything outside is vertical and tells the truth. Everything inside is horizontal, and it's a lie. When I'm horizontal, I'm lying down. Multiplying changes the steepness, adding and subtracting changes. It shifts it either up, down, left, or right. All right, guys. I hope this video helped clear up some things you weren't sure about. Have a great night.